Welcome to Lab M-3, Equilibrium of Forces and Torques, or, as you may prefer to think about it, the Balance Lab. Now in this lab, we are going to balance this derrick in a position of unstable equilibrium. Now, I'll bet that you're enough of an expert in balance to tell that there's something a little fishy as I pretend to balance this derrick in a position of unstable equilibrium. And you're right, because after all, I'm not balancing it in a position of unstable equilibrium. I'm merely suspending it from a string in a position of stable equilibrium. Let's draw a free body diagram of the derrick as it hangs suspended from the string. We know that there are two forces acting upon the derrick: the tension of the string acting upwards from the point of support, and the weight of the derrick, which acts downwards from the center of mass. Now at this point, we don't know where the center of mass is, but we do know that if the object is observed to be in stable equilibrium, the center of mass must be directly below the point of support. Now, suppose that you didn't know that the string was there, and instead you thought that I really was trying to balance the derrick on my hand. Then you would think something fishy was going on, because even if n equaled mg, this object would not be in equilibrium. It would start to rotate because the forces don't line up. Now, here is the derrick as you will eventually set it up in the lab. The derrick rests on a crossbar down here, and it supports a weight hanging from a string over here. And this is balanced by a counterweight, which is hanging from another string, which goes around the pulley and attaches over here. And the whole derrick can move like this on the crosspiece. Now this lab basically has two parts. In the first part, you will make a calculation based on your knowledge of this weight, the weight of the derrick, some distances that you may have to measure, and your knowledge of the equilibrium conditions that the sum of forces must be 0 and the sum of torques must be 0, to predict how much weight you would need to put over here in order to balance the derrick in a position such that the top part is horizontal. There is a level mounted on top of the derrick to allow you to tell when the top of the derrick is horizontal. The second part of the lab is the measurement part of the lab. Then you'll actually measure how much weight you need to add over there to balance the derrick with equilibrium such that the top part is horizontal. Here's how you do it. First, you take the derrick and by looking at the level, get it horizontal. And then you let it go. All right, if the derrick falls this way, I need more weight over there. I'll add some more weight over there. I put it back so it's horizontal. I let it go. Falls this way again. I need to add more weight. Add another kilogram. I put it back in a position of horizontal equilibrium. I let it go. It went that way this time. Too much weight. It's important that every time you change the weight, that you bring it back to a position of horizontal equilibrium before you test it again. Now what we want you to measure here is the smallest weight, which is definitely too much to get this thing into equilibrium. And also measure the largest weight, which is definitely too small to get it in horizontal equilibrium, because you'll not be able to measure it perfectly. You get it in horizontal equilibrium like this, and if you add just a little tiny weight very carefully, nothing will happen. You won't be able to perfectly measure the amount of weight necessary to get this thing in equilibrium with the top part horizontal. Here are some tips. You want to set up the string so that it doesn't rub against the orange bracket over here. And you want to make sure that the derrick isn't rubbing against the sides of this collar up here. And that's it for Lab M3. Good luck in the physics lab.